1.3 laws of logs. So we're going to find out how to solve logarithms and simplify them where we can solve them without actually using our calculators by knowing certain rules. So let's see how we do this. Well, first of all, they relate and they do the exact opposite of our exponent laws. So with exponent laws, our first exponent law is when we multiply bases, we add exponents. So that means if I've got a log where the arguments are sitting side by side, okay, they were multiplied. Multiplying means I add over here, and when I split them, I'm going to put a plus sign between them. Okay, that's all it means. Okay, so if they're sitting side by side multiplied, to split them, you separate them and put a plus sign in. Okay, but they each get log base A. Log base A, log base A. Okay, so m times n, you split them, m gets 1, n gets 1. Okay, so they were split. Now, if they're divided, it means that there was a subtraction sign in there instead of a plus sign. That's all it means. We did the exact same process. Now, what if there's an exponent on the m part? What happens to get that exponent off the m? We put that exponent out front. It becomes the a value out front of log that tells us it's going up or down. Okay? So that's what the exponent does. So if we want to get this out of exponential form and remove that n from the exponent, we put it down in front of the word log. Okay? I'll do a couple examples of these as we go through. Then we have this concept right here. When our log base and the argument are the same, the answer, it's like dropping the base because they're identical. The answer is the exponent left over on the argument. So the argument is always this big letter. Okay, the big one right beside log, not the baby one that's the subscript base. So this one here, the A, it's got a hiding 1 on it. So if I take my rule that says if the log base and the argument are the same, they cancel, then my answer is 1, which is the exponent. So your answer is the exponent on the argument. Okay, and that's a law we use a lot. We use that one a lot. Okay, so I'm going to do a couple examples of the first 3 here that we have, or the first 4, and then we'll talk about the 1 and 0. So for the very first one, I could write log base 3 of 5 plus log base 3 of 7. What is that telling me to do if I combine them? If there's a plus sign in the middle, how do I combine them? I take the 2 numbers and I do what to them? You multiply them. That's what this is showing me, multiply. So that means I'm going to do this. I'm going to have a log base 3 of 5 times 7. That's what it's telling me to do. Now, what actually is telling me to do that? The plus sign is telling me that they're multiplying. Okay, the plus sign is telling me they're multiplying. So now to simplify that, I would have log base 3 of 35. And then I would do change of base. To solve it, I would go log 35 divided by log 3, and I would solve it. Okay? That's how you solve those. Okay, write that example down. Am I not taping?
It's at the bottom.
It's the bottom? I don't see it anywhere. Oh, okay, yeah. Our next example, let's take a look at the division one. We'll do an example of the dividing. So if I take an example of this one, that would be like saying log base 2 of 15 minusing log base 2. They have to have the same base in order to follow the log laws. Log base 2 of 3. In order to combine those, they have the same base, so I'm allowed to use the rules. So it's still log base 2, but now it's telling me to take 15 and divide by 3. Okay? What tells me that? The negative sign, the subtraction between them. That's what's telling me to combine them by dividing. So now if I can actually solve that, I do. So I'm going to end up with log base 2 of 5. Okay? And to simplify it further, I would take log 5 divided by log 2. Okay? Okay, let's do an example of the third law here. So if I've got something that looks like this, log base 5 of 7 cubed. To rewrite this expanded, I would take that 3 off the top and I would move it in front of the word log. So that's the same as saying 3 times log base 5 of 7. Okay? I can work backwards now. If I'm given it with the number or variable out front of log, I can put it back as an exponent. So let's see how I would do that. Here's another example. I could take, let's go with 1/2 log base x of w. Okay, 1/2 log base x of w. I want to combine that now. I want to show that this 1/2 is going to go on the w. Okay, I'm just working backwards. So what happens now is this 1/2 out front is going to become the exponent on my w. So I would rewrite this now as log base x of w to the 1/2. I could write that one other way. What do I know about exponent 1/2? What would it become? It would become a square root. Whenever you see the 1/2, if it's a fraction exponent, it means that the bottom number is the index on your radical. So this is the same as me saying log base x, w now, it's got my 1 and my square root sign. Okay? The 2 is the index on the root sign, don't forget. The 1 stays as the exponent. Okay? That's how that works. Okay, we're going to take a look at the last 2 now. So an example of this one, I could do this. So that is the same as me saying log base w of w to the 15. Okay? Log base w of w15, exponent 15. Well, when the argument and the base are the same, you drop them, the answer is the exponent. So I drop those, my answer is 15. Okay? It's like dropping our bases. Okay? Another example that we could do like this could be like something that looks like this. If I've got a log base 6, let's say of 72, or actually let's say 216, I want to simplify that. If I want to simplify that using the law right here, then what I'm going to do is I'm going to change 216 into the same base as my log base. Well, I know that 216 can go to base 6, it's 6 cubed. So I'm going to rewrite this as log base 6 of 6 cubed. Now my bases are the same as the argument. They can drop. My answer would be 3. Okay? Now you can solve it like change of base the way we did before, where we took log 216 divided by log 6. You can still do it that way. You'll still get the same answer, 3. Okay? This is how we would simplify it without using our calculator, just using the rules. So let's take a look at the very last one now. The very last one is log base a of 1 equals 0. Well, what does that actually mean if we change to exponential form? That means a exponent 0 equals 1. Well, and that's true law. We know that anything exponent 0 equals 1. Okay? So that's why any base, a can be absolutely any number, except for a negative number. Our bases are not negatives. So a can be absolutely any number. Okay? As long as it's above 0. Any question on that? No? Let's take a look at a few examples. We want to evaluate these, but we want to simplify them using log laws first. Okay? So we're always going to simplify first if we can. So in the first step, we see a plus sign. The minute I see that plus sign, that's telling me that I need to multiply something. Okay? And which numbers would I multiply now to combine those? You multiply the arguments. So the ones I'm going to multiply, so I'm going to multiply the 100 and I'm going to multiply the 1/4. That's what I'm multiplying when I combine it. Okay, those are called the arguments. So this is going to look like log base 5 of 100 over 1 timesing by 1 over 4. Why did I change the 100 and put it into a fraction? because the 1/4 is a fraction. And then you can use multiplying rules for fractions, where you multiply tops, multiply bottoms. When I do that, I'm going to get 100 divided by 4. And we all know that 100 divided by 4 is 25. So this further simplifies as log base 5 of 25. Now I can use that Basin argument rule, where I can convert my argument to the same base, drop your Basin argument, you get your exponent answer. So this can further simplify as log base 5 of 5 squared. Now my log base and the argument are identical. I can drop them. My answer is 2. So the answer to this one up here is 2. Okay, we found our answer for the top one was 2. Now it says we're subtracting in example 2. The minute I see that subtract sign, I know I'm going to divide. And which numbers do I divide now? Again, it's your big argument numbers you divide. So, to simplify, I would rewrite it to look like this. Log base 2 of 384 divided by 12. And now you actually do the dividing if you can. And 384 divided by 12 gives me 32. So I'm going to simplify by going log base 2 of 32. At this point, you can change 32 to log base 2, or you can go log 32 divided by log 2. We're going to use the log laws. So we're going to change him to base 2. Okay, so we're going to change him to a base 2. So what we get is our log base 2, and 32 becomes 2 exponent 5. Now that my log base and my argument are the same, they drop. My answer is 5. Okay, first example we got 2, second example we got 5. Third example, what are we going to do with example 3? I see a plus sign, so we're going to multiply our arguments. Our arguments are binomials. So I need to remember how to multiply binomials as polynomials. So to do that, I can FOIL these. Okay, so you can FOIL them, or you can put them in an area box. I'm going to put them in an area box. So you're going to have a plus b, a minus b. All right, when I multiply, I add the exponents on them. So I'm going to get a squared only if they're the same variable. If they're different variables, you just write them side by side. So a times b is just ab. A times negative b is negative ab. And b, both b's have hidden ones on them. So you're going to get a positive times a negative gives us a negative b squared. That's one of our difference of squares examples. So what we're going to notice is that this one and this one cancel out and give us 0. So we do not have to write them down at all. Okay? So what we're going to redo now is we're going to write this to simplify. So let's rewrite the equation. So I've got my log of a plus b, and with the plus sign means I'm combining it. A minus b, when they sit side by side as brackets, it means multiply. Okay? So they're multiplying right now. I multiplied them and I get this. So now my log becomes this. Log of a squared minus b squared. And you are done. You cannot go any further unless you know what a and b are specifically. Okay? You cannot go any further. Okay? Take a minute to write that down. Okay, moving on to example 4. There's lots of variables here. I cannot combine any of my logs if they've got a digit written out front of the word log. I've got to take that digit and put it back on as an exponent. So that's always your very first step. So this 3 is going to go back on a B, and that 5 is going to go on that C. Okay? So we rewrite our equation like this. Log A minus log b cubed plus log of 5th root c to the 5th. Okay, so that's how we simplify that step. Okay, moving on. At this stage, you're going to see that something cancels. Opposite operations always cancel. So you're going to see the 5th root and the exponent 5 cancel. So all we have left here is just log c sitting there. So when we combine them, if we've got more than one expression to combine, we take the first two and combine them, rewrite it, and then put the second one and combine it. So we would take those two first. The subtraction sign means I'm going to divide A and B. So it's going to look like this. Log A over B cubed. And because it's a fraction, it must go in brackets. And then I tack down the rest of the expression. Plus log of C. C is no longer under a radical. Now, plussing, when I combine these two at this point, because I'm plussing, it means I'm going to multiply C. Okay, I'm multiplying C into the other variables. But the variables are a fraction. Well, don't forget, C is also a fraction over 1. So C, that means it's going to multiply to the A, not to the B, to the A. Now, when we multiply variables, you don't know what their value is, so you just stick the letters side by side. So this is going to simplify as log A times C on top of B cubed in brackets, and that's as far as I can go. You cannot simplify any further unless you know what A, B, and C are. Okay, moving on. Now we want to combine these. But what we're going to see is we've got an expression on the left-hand side, and then we've got an expression in brackets. So according to BEDMAS, again, I always simplify my brackets first. So that means the first part of the equation I'm just going to write down by itself. So I've got log base x10 plus log base x75 minus. Now I solve in that bracket. That bracket, because it's plussing, is telling me to take that 2 and 3 and multiply them. So that's going to give me log base x of 6. Does everybody see where the 6 comes from? Okay, I've multiplied the 2 and the 3, and I get my 6. Now I work left to right. Okay, now I'm going to work left to right. Again, what you're checking, are the bases the same? Do they match? They must, otherwise you cannot simplify them. So these are all base x, so yes, I can simplify them. Okay, if they were different bases, you can't. The log laws don't apply if they're different bases. So now I'm going to combine the first two. So I'm going to take 10, plussing means I'm timesing by 75. So I'm going to times those two numbers. So that's going to give me log base x of 750. Subtract log base x of 6. Now I simplify these two expressions. And by simplifying them, the subtraction sign tells me I need to divide my big numbers. So I'm going to take my arguments, 750 and 6, I'm going to divide them. So it simplifies further as log base x of 750 dividing by 6 is 125. Okay, that's what we simplify to. Okay, that's what this whole giant top expression gave us. Now on part B, it's saying, solve it if x is equal to 5. So now, I'm going to put a 5 where the x is. Okay? I'm now going to put a 5 there. And now I need to solve that. So we can do it two ways. You can go log 25 divided by log 5, or let's use log laws. We know that 125 gives us 5 cubed. So that's like saying log base 5 of 5 cubed. And what do we know when the argument and the base match? They cancel or drop. So your answer is 3. Okay, that would be the part B up here. That goes right here. I just write really big. Okay, that's what we get for that section. Okay, let's take this one up now. You've had time to work on it. The 2 we put on the 4 as an exponent. So we're going to get log base 6 of 4 squared plus log base 6 of 2.25. Now I evaluate the 4 squared part. I solve that part. So I get log base 6 of 16 plus log base 6 of 2.25. If you're able to skip those steps and you know that 4 squared is 16, at this point now, because I'm plussing, all you're doing is multiplying the big numbers. So you're going to multiply 16 times 2.25. At this point now, because we're adding, we're going to multiply those two numbers. So we get log base 6, 16 times 2.25 gives us 36. At that point, I know that 36 can be a base 6, the same as my log base. So I'm going to convert that as log base 6 is 6 squared, because 36 is 6 squared. Now my log base and argument are the same. I can drop them. My answer is 2. Okay, taking a look at this one. This one's telling us that this whole value, log 5 of p, all of that equals the digit 12. So whenever you've got that, it will disappear and you replace it with a 12. So right here, I bring the 5 down. This part gives me 12. When they sit side by side, it means you multiply them. So this one evaluate is giving me 60. Okay? Now the only reason that works is because in this specific question, they're saying log base 5 of p equals 12. Okay? They're actually telling us what it equals. Okay? It can be equal to any value, and that's what they're telling us. Okay? Now let's separate the second one. On letter B, how am I going to separate B? Well, first of all, those guys are sitting side by side, the 5 and the p. So that means they were multiplied together when they sit side by side. How do I separate something that was multiplied? How do I separate it? No, we don't divide. We separate them by adding expressions, okay? Remember, multiplying is adding, and subtracting is dividing. Okay, you gotta think log laws, not exponent laws. So, this would have started like this. Log base 5 of p plus log base 5 of 5. That's how it would have started. Okay? That's how that expression would have started. How do I know? Because I've got a 5 and a p sitting side by side. So that means they were two expressions that were added together. So I can put that 5 and p side by side. Now we know that this part of the equation gives us 12. That's what it's telling us up here. And then now I can evaluate the right-hand side. I've got a hidden 1 on my 5. Well, my base and my argument are the same. I can cancel them. My answer is the exponent. So here I've got 12 plusing 1. My answer is 13. Okay, the answer is 13 for B. And the only reason it's 13 is because they're telling us that log base 5 of p equals 12. They're giving us a value for that answer. Okay, now we're going to try letter C. You ready for C? Yeah? Okay. Okay, letter C. We see a couple things. We see log of base 5 of 25 p cubed. So we know that it was 25 times p cubed, correct? Okay, so I'm going to separate that the way I did letter B. So that's going to give me log base 5 of 25 plus, because they're timesing, log base 5 of p cubed. Okay? Now I'm going to take off the exponent 3, and I'm going to put it in front of my log where it belongs. So the 3 belongs out front here, and I'm going to solve the left-hand side. The left-hand side of my expression, I can simplify to log base 5 of 5 squared, because 25 becomes 5 squared. Plusing 3 times log base 5 of p. Now, as I continue to solve that, I've got the same bases matching on the left. I drop my bases, I get a 2. My plus sign comes down. The 3 comes down. And it's timesing by what all this is. And log base 5 of p, they tell us in the question, equals 12. So now I put a 12 where that log base 5 of p is. So now I can simplify by doing BEDMAS. I get 2 plus 36 is going to give me 38 as an answer. Okay, we take a look at the next expression. We've got log base 2 of x equals a. We want to prove this simplifies to this answer. So that means we need to use our log laws and separate it. So I'm going to do log base 2 of 32 plus log base 2 of x squared. Now, why did I separate the x squared and 32? Because they're sitting side by side attached. And when they're side by side attached, it means multiply. To separate a multiplied log, you put a plus sign between them. That's how you separate them. Okay? Now, I'm going to put my 2 on the exponent out front my log. That's my next step. You always want to get rid of those exponents in front of log if you can. So I write my left-hand side. I'm going to change 32 to a base 2 as well. So I've got log base 2 of 2 to the 5th. That's what 32 gives me. 32 gives me my 2 to the 5th. I added 2. 2 times, that's where my big 2 off my exponent goes in front. Log base 2 of x. Now in this question, at this point, they're telling us that this part of the equation is equal to the letter A. So where that part of the equation is, I put the letter A. Okay? Now on the left-hand side, my base and argument are the same. I can cancel them. So my 5 comes down. So I get a 5 plus 2 timesing by, this is replaced by what they show us here, the letter A. So how do we write 2 times A? It's just 2A. So that my final answer would give me 5 plus 2A. And that's what they wanted me to prove, that my answer is 5 plus 2A. Okay, on this one, what happens when our log base and argument are the same, or if the argument can be written with the same base? What do we know? We drop them. We drop them, and the answer is the exponent left over. That's one of the laws we've been using already. So, here I would drop my logs. They are the same base and argument. My answer for the first one would be 5x minus 2. That's my exponent on my big 6. If I look at the right-hand side, I know that 81 can be written as a base 3. It's 3 exponent 4. So I rewrite my log as log base 3 of 3 to the 4th power. Then I have an exponent already on my 81. So I need to multiply the 4 into my 2x plus 1. Okay, so now that we're at this point, we take our outside 4 and we multiply it into our exponent. So we end up with log base 3 of 3 to the 8x plus 4. Now that our log base is the same as our argument, they drop. My final answer will be 8x plus 4. This concludes log laws part 1.